I'm really pleased to introduce Yanping Ma from Loyola Marymount University, who's been a colleague for a number of years and is one of the co-organizers of this conference. And I think she probably couldn't resist knowing this was going to come on the Chinese Lunar New Year to put the word dragon in here somehow. But she's going to talk about her modeling a first approach in ODE classrooms utilizing fictional dragons as practical modeling illustrations. So take it away.
Thank you, Brian. And thanks everyone for coming. I just want to mention first that I'm using a full screen presenter view, so I can't really see everyone's face. If you have questions, feel free to unmute yourself or just type in the chat. I can still see alerts in chat, so sorry about this. So good morning and happy Lunar New Year to whoever celebrates. So thank you for coming for my talk. So, well, today I want to share my plan. It's not something I actually have already done. This is my plan. Like Brian was saying, this is a year of dragon, and I see this project and I feel like it's a wonderful thing to do in my classroom. So I want to share my plan to model how dragon would live in real life in an ODE class this semester. And I have special projects designed for teaching some other things as well. So it's not completely carried out yet. So whatever I'm talking about today will be open to any questions, suggestions, or concerns if you have any. So just feel free to let me know. Thank you in advance. So I want to mention I'm from Loyola Marymount University. It's a private Catholic university. We're about 5 minutes away from the Los Angeles airport. So if anybody is around, feel free to shoot me an email. We have beautiful campus. I would like to you to have a visit. So our department is part of the College of Science and Engineering. So the whole university have about 6,000-7,000 undergraduate students, but our department is very small. We have about 10 to 15 undergraduates each year for math major, even though we kind of doubled, the enrollment doubled since fall because of our new statistics and data science major, but they don't need to teach ODE, they don't need to take ODE class, so it doesn't really matter to the size of this course. Therefore, we have about 5 sections. Each section have about like 24 students each semester, total 5 sections a whole year of for ODE classes. So we don't really have a lot of audiences, but also the small class size allows me to do a lot of things that I enjoy. So when I teach this course, we have students mostly from engineering, all types of engineering, and we have some math, some physics, occasionally we have biology and econ students in our classroom. So I'm a biomathematician by training. So in my research, I use differential equations on a lot of topics. And so it's always a challenge to bring interesting topics that might attract students who majors in engineering, and that's majority of my classroom. So I constantly thinking about what other things I could talk to my students about, but also might be interesting to them, not just to the 1 or 2 biology students I have in my classroom. So after all those years of teaching differential equations, my general feeling about teaching this course is that a lot of us are kind of focused on teaching the different specific topics or techniques of solving differential equations, such as like the integrating factor method or solving the exact equations and so on and so forth. But like I said, my research is like almost 90% about differential equations. So I feel like I don't really use any of the things I teach in my classroom technique-wise to solve actual problems. So it's very frustrating sometimes when we teach the class. One of my colleagues really told me once that he hates teaching differential equation class because he is not inspired by the things he taught in the classroom. So for me, what I begin to do is that I changed my way of teaching completely since I joined the Mindy workshop in 2022 in summer, organized by Brian and Samuel. Then that's why I get involved a lot in Samuel, because that definitely changed my way of teaching. I switched to the side where I can teach more modeling in the classroom. So for me, I think the good way of teaching after this years of changing, I feel like the best way to teach is to cover only a limited number of techniques don't cover all the full plate of recipes, and train our students to solve, train our students to learn solving methods by themselves. Now we have ChatGPT. They can have like guided free tutors to help them to point a direction where to learn, and then we can focus on the modeling part. And it is essential to give some instructions about solving ODE numerically, such as by the most basic Euler's method. So with the help of AI tools such as ChatGPT, right, both our keynote speaker talked about it, it's not hard to find resources about other standard methods of solving types of DEs. So our students can learn everything, but also get a good experience and find something that's really interesting for them to learn and remember after they finish the class, not forgetting every single technique they learned in the classroom. So for me, the modeling first approach is very good because it definitely enhances engagement. It doesn't really matter whether students are very good at math or not. There are always something they can do in the classroom. They can develop deeper understanding. They won't be, I used to have students telling me halfway through the semester, they feel like they are master of all types of techniques, but they don't really know what they're doing in the classroom. I feel like they can develop deeper understanding, and definitely they will develop different types of skills, because doing a lot of modeling means they have to work with others, they have to communicate with each other, and they have to come back every time to talk about iterations of different improvement of those models. So it's definitely developing their quite critical thinking ideas. My skills, my 5 list here on the left is actually the answer that I asked ChatGPT, why should we do modeling first approach? And those are the answers ChatGPT gives me. But for me, I think the most important part is the 3 items left on the right side, which is my deepest feeling. Anyway, so my opinion in general, model it early in the classroom, ask our students solve it, and solve them numerically, not by hand. So like I said, I struggled to find resources, and after all these years, I finally find several good places to find good resources to use modeling projects to use in the classroom. Of course, we have CMAID and open resource materials, and we have Scudem, and we have the MCM competitions. And Brian has mentioned the special issue we worked on, published on EdgeMest, and they all have class notes. They have class notes published regularly as well. So there are other materials that's not included in our special issue. So I've used many materials from CMAID in the past years, and I begin to develop some new myself. The ones I've used, for example, I keep doing the first day activity of the counting red beans, different types of beans, to model spread of infectious disease, which was very exciting. My students talk about it all the time. And also I myself and my colleague, we published on the special issue Brian mentioned earlier. And this is something we're going to use this semester. So it's about the love relationship that we can model. The good thing about it, it's a bundle, and it's relatively culturally sensitive. So we do a 5-part bundle of activities in the classroom. Their students can draw from their personal and cultural experience with the concept of love. Students can develop different types of scenarios, model them from the background they enjoy, identify limitations, and offer future model revisions. And the good thing about it is we know modeling is a iterative method. So we're going to revisit improvement of the model 3 times in the semester on Valentine, White Valentine, Black Valentine, which by the way is an East Asian thing. So don't get scared if you have never heard of the later two. Anyway, back to business. So, it's published on EdgeMest. It's just out earlier this year. So back to the business. What I want to talk about is bringing imaginary creature into the classroom. And it's a year of dragon, that's the best time to talk about this idea. So the general question is to model, analyze, and report back about what would happen if the fractional dragon can live today. this is the first problem in the mathematical context in modeling organized by the Consortium for Mathematics and its Applications. So students can form a team of 3 and spend 99 hours to work on the project. By the way, this competition has a new regulation on the use of large language models and generative AI tools. So it's interesting to take a look at that if that's something you are interested to know more about. I read about it and I find it's quite helpful to understand other people's way of thinking about how to use the new fancy AI tools nowadays. Anyway, the expectation is for students to model, analyze the dragon's characteristics, behaviors, habits, diet, and interactions with their environment. Students should discuss the energy expenditures of the dragon and a lot of other things involved in their growth and also effects on climate. And the most important thing is write a 2-page letter to guide the author about how to maintain ecological realm in the Fictional story. So it's like the kind of like the executive report. Brian, I learned from Brian before, so I really like the structure here. Okay, so my plan is to talk about the way of thinking to students and guide them throughout the semester. I will talk about the time plan towards the end, but I want to talk about the general idea just very briefly here. So I take my crack of this on this problem. So I think the logic of thinking should be, I want to connect to the environment. And well, if we forget about the waste and other things a little bit, we focus only on the food intakes. Then for food intakes, it should be coming from the energy needed for the dragon to survive. And the energy needed for the dragon to survive should be coming from the growth of the dragon. So by this backward design, I think those are the topics we need to talk about when we try to build the model. Therefore, changing from going backwards, the moving forward, the things we should model should be the growth of the dragon, which leads to the metabolism of the dragon, which leads to the energy intakes of the dragon, which leads to the food intakes of the dragon. And then we connect that food intake of the dragon to the surrounding environment. Okay, so this is my way of thinking. So we try to find the information about every single piece we have here, and I got a lot of help from ChatGPT to guide me through the types of models, because I'm pretending I'm a student who don't really know all the fancy tools, and I'm not majoring in I don't know, pretending I'm majoring in computer science. I don't know a lot of things that's related to growth. So what are the things I can find? Well, with the help of the AI tools, I generally know that I should be looking for some kind of ACE-shaped growth curve, right? At the very beginning, the growth is very slow, and there was a time where, just like humans, we grow very, very fast. And once we reach to the age of, let's say, 20, our weight, our height, like doesn't really change much. So we are looking for an S-shaped curve. So though we find multiple ways to model growth. For example, the VBGF is particularly popular. The first one we have here in fisheries science for modeling the growth of individuals in population over time. The second one is often used to describing the growth of tumor and certain animal population. The last one is widely applied to ecology to describe how population grows with the constraints of the environment. So we have a lot of options for the students to choose from and to argue with one another what might be the best one, or they can just play with all of them. And so they can model the growth, the weight change of the dragon over time. And once we did that, we want to connect it to the metabolism. And well, like before, I don't know how to study metabolism other than with a Google search or with the help of ChatGPT. So we can find that the basic metabolic rate, BMR, can be modeled by something as simple as B0, a base rate, multiplied by the weight to the power 4/3. But of course, like we said, one good thing is to always go back, think about the ways, the limitations of your model and the ways to improve your model. So there are many things we could have incorporated if we dive into metabolism. For example, if you live in Alaska, or if you live in Texas, of course, because of the differences of temperature, right, we would predict the metabolism would be significantly different. And I'm 100% sure our student athlete, their metabolism rate is much higher than me, who barely exercise. So the activity type also is something that's quite important. So there are many factors our students could consider and could build in if they have the time and the energy to study all those different types of variations. So just a quick demonstration. So if we have minimal activity, then the metabolism is, generally speaking, 1.375 times of the B naught of the baseline. And for the professional type, it's all their metabolism almost doubled of the B naught. Anyway, it's a good idea to consider incorporating activity type in the model as well when we try to build the metabolism into the formulation. And of course, once we build in the metabolism, then we have the weight, which helped me to understand the metabolism. And then we can talk about, okay, what actually is the energy we need to build into the system to understand the dragon. We have the basic information. We can consider where does the dragon would live, right? Near a volcano or in North Pole. And what type of lifestyle do we predict them to have? And there's, of course, extra calories the dragons need in a certain age when they grow very quickly. And of course, body composition is something that we want to include as well, because if they were to eat something, if you just drink water, or if you were to eat fat only, right? There are many different ways because of your diet. It's gonna affect your calorie intake. So we try to build those information into the system as well. So if we think our dragon is like the carnivorous reptile, then when we try to build our model, we would only talk about the meat intake. We just assume water doesn't really contribute anything. Versus if we were talking about our dragons, where they're herbivorous type, if they only eat grass, right? Or if they eat both meat and grass, what type of environmental connection they would have. So when we try to model, our food needed should be related to the meat and to the grass. And by the way, all the dragons and all the pictures here are generated by Dolly. So here's one first attempt to build our model. So for example, if we were talking about the type of the dragon, which only eat sheep, of course, we can include many other types of food sources. Nobody said it has to be sheep, right? We can have pig, we can have other types of animals, then we can have a competition. We try to keep it as simple as possible. And the easiest one to have is the predator-prey model if we only have sheep and wolf, and we build our dragon in. So we modify our predator-prey model a little bit, and then we can kick our dragon in. And I think I forget to write. Oh no, we're good. So in this case, the grass growth model, of course, you see our growth term here, right? And then we have a natural dying term of the grass. And then there's a dying term that's caused by the sheep population. And our sheep, we have a production rate, which was affected by the number of sheep we have and the amount of grass we have. And then there's a natural dying rate, and our sheep are gonna be hunted by wolves. I think I made a mistake about the last term. Sorry, I did a last minute modification right before this talk. I don't know why I keep this one here. It shouldn't be there, my bad. And it's easy to model the wolf population. So we can easily capture the food sources we're gonna have, and then we can incorporate this into, we can modify this model and put our dragons information into it. Oh, I think I understand what I did wrong. My bad. Like I said, I did a last minute modification. I think what I meant to say is I have a minus C2 and minus C3 here. Those two terms are the sheep and wolf that's been captured by our dragon. My apologies. I did a last minute modification. I don't know what I was thinking 5 minutes before the talk. Okay, so the skeleton of the project is we need to have a basic understanding to translate everything mathematically. We need to consider develop our model. And of course, there's always assumptions we need to build. And then we have our models and we try to solve it. There are sensitivity analysis and results interpretation later, of course. And then we need to write about the letter, which is gonna be our summary report to the author. So to finish this whole thing, my tentative plan is the first week of class. I've already told my students, this is something we're gonna try to do this semester. And then the second step we've already done, when I introduce ODE classification and Euler's method, I like to begin teaching differential equation with Euler's method, because I hope that's, if there's only one thing to remember after taking ODE class, I hope that's the thing to remember. Anyway, so while introducing this, I told them various ways to model the growth, and then we can use Euler's method to see what the solution curve is gonna look like, so they can compare the differences. And we are pretty much done with the first order differential equation. So we will be talking about the dragon growth, and we talk about metabolism very shortly next week. And later throughout the semester, when we talk about each of those topics, second order linear ODE or system of ODE, we are going to touch different topics of food intakes and see a few words about what exactly is the sensitivity analysis. And then we're gonna introduce a predator-prey model and ask students to modify it. And then ask students to try to use Euler's method to solve systems. And when we introduce Laplace transform, when things were completely switched to a different gear, we will talk about how to prepare the report, and also, of course, see a few words about linearization and ask them to consider if this is something can be solved by a Laplace transform method. But anyway, the plan is to, every time I teach some technical content every other week, towards the end of the course, I spend about 30 minutes to mention modeling, trying to touch back to what the theme we have. So hopefully this touching back on regular basis gives students a chance to get more engaged and get more interested in using differential equation. I know I'm running out of time, so just some of the references, the things I talked about, and I'm open to questions, comments, and suggestions if you have any. So thank you very much, and let me know if you have questions. I think it's kind of, sorry, my computer froze. Okay. Thank you. Like I said, it's a plan. It's not something that has already been executed. I'm just like, I'm still at stage number 3 here. So whatever you have in mind, just shoot. Thank you.
So you're going to you're threading this dragon model all the way through the course, which is kind of I think it's a great idea. I mean, you pick your favorite and move it.
Right.
And you did have some data early on for different not body types, but lifestyles, almost, the professional. So
right.
As you go, you're going to have to decide how many wolves the dragon eats per day or whatever, right?
Right. I want students to choose the type they want to study. So there are many ways they can change things up and just play around. And also I want them to find actual information online for a particular region. If your dragon were to, let's say, live in Australia, or if your
Okay.
dragon were to live in, I don't know, mountain area or in the, at different places, what's the data you can collect there? And of course, you can add other types of animals, not just sheep and wolf, to get in the way. So I think it gives them room to do a lot of things, depends on their ability. And they can do a fancy one, they can do a simple one, but I kind of provided enough information so they can play things around a lot. Yeah, but my the incentive is it's a dragon. I just find it's nice to do it in this year.
Fun.
So Dan, you got a question?
Yeah, a question and a comment. Thank you so much. This was fantastic. I love incorporating things like, humans versus zombies for predator prey, and this dragons
me
will fit
too.
right into that. I had two quick questions. One, I was wondering if you had resources for how they're going to estimate the parameters, or is this kind of a look this up and play around with different values and see if there are bifurcations
So
idea? 'Cause that's always the hardest part sometimes for them.
yeah, exactly. So I'm not super confident about doing anything fancy. So I would give students suggestions. Those I would like you to play with several parameters yourself, make the decision yourself, and then do sensitivity analysis and just see how things change. What are the important factors, and just report back to me. What are the parameters, if you have time, you would spend more time to discuss? So I'm not seeing it as something giving me accurate predictions, accurate parameters, but I want them to have a try. So in the future, with more understanding, they can solve optimization problems, things like that, to identify parameter a little bit better.
Oh, that's fantastic. That's exactly what I would do as well. So I'm glad to hear that I'm not just making stuff up. And the other question was very quickly about the model. I know you said you changed it right before the session, but I was wondering, you had the C1, C2, C3 in terms of S, W, and W again, I think. And I wasn't quite sure. I didn't know if you could touch on that again. There's the constant death rate. And then I'm guessing the C1S is a constant rate of the sheep eating the grass, for example?
So grass have a C1 times that. So grass is gonna be eaten by sheep. So there's that, and then the sheep is gonna be there's natural disease, natural death, and it's gonna be eaten by wolf. So there were two terms.
Got it.
For the,
okay.
And then there's there's a minus C3, which is dragon. Dragon is gonna eat the sheep and gonna eat the wolf.
Right. So that would be in both of them.
Right.
Coefficient. Okay.
And I'm assuming one dragon. I'm not assuming a lot of dragon.
And that's why you're not multiplying the S by the. Okay.
Right.
Fantastic.
One dragon.
Right, thank you.
Let's turn to Carrie. She has a question. She's in New Zealand, and she's worried about all these dragons coming to eat up all the wolves, the sheep in New Zealand.
I know. That's why earlier when I say the example, I was like, hey, if we have a dragon, I thought about it. I thought about New Zealand, and then I'm like, oh yeah, Australia, not New Zealand.
So what was your question?
Things have changed a little bit down here. We now seem to have far more farmers farming cattle opposed to sheep now. So things are changing.
Ooh, okay, good to know.
Well, Carrie, you had a question. I have to leave soon, but you can keep going.
No, that's good. That's good. Thank you very much. That was really, really inspiring. And it was really, really inspiring. Like you sort of working in the two spaces, this fictional space, along with sort of that sort of space where you can guide the students, but give them some freedom to make their own choices. It's very exciting. Yeah. And it's more than anything, because I mean, for me, we've tried something similar with, but not fictional, with secondary students. And one of the things I loved what you did is the way that you'd actually gone through and really pinned down some key phases of the model development for students and got the information there to make options. Now, I was just wondering, how useful did you find GTP to be? Because I found it fascinating that you use that to help.
So, I mean, I'm a big supporter of ChatGPT. So, yeah. I think maybe you were in a session yesterday. I have been paying for using it for like more than half a year already.
Yeah.
So
Yeah.
I find it super helpful when you move into an area that you have no knowledge at all. I'm not saying to trust there. I mean, we can't even trust Wikipedia 100%, right? I'm not saying just to trust everything that gives you, but it gives you some directions you can look into. So, I mean, I feel comfortable about bringing those projects now because I can tell my students, if you want to model growth of something, you can just ask ChatGPT, what are the existing models that's widely used there? They give you several lists, and then you can say, oh, what are their differences, right? I mean, they are not all accurate, but I trust our student would look into those. They have to start from somewhere. So they have names to look into. I wouldn't know how to model metabolism myself without the help of ChatGPT. But yeah, with Google, sure, eventually, right? But I just find it's quite helpful and quite efficient, and I definitely love it. And the other thing is, I like to ask students to solve things numerically, because I think that's the only thing that's most important. Hopefully after taking the course, they will, if they have to solve differential equation in the future, that's the way they're gonna go. So ChatGPT is very good at interpolating. We know it's hard to read other people's code, right? So it's not too hard to find some existing code solving systems of differential equations. And what I try to do now is, I'm not good with Python, I'm good with MATLAB. I copy some MATLAB code, I put in there and say, could you rephrase it, explain it to me, what exactly we're doing, and then can you write it in Python for me? So students using different language, I don't have to worry about that anymore, because we used to teach MATLAB. Now some department teach Java, some JavaScript, some department teach Python, and our SDS students are learning R. So I have this phase of worrying about, if I give them MATLAB sample code, do they really know what am I doing here? And how do they do it in the language they feel comfortable? And I feel like ChatGPT, I mean, again, not perfect, but it can help them to get started somewhere. So I'm less concerned about the language they use.
Yeah, that's fascinating, because what we found is because we did an open-ended project with students actually at secondary school here around them, investigating into the affordability of future housing for them, because that's a massive issue here in our country, particularly for lower socioeconomic areas, that basically the average New Zealander is getting pushed out of the housing market here, unfortunately, been going on for a few years. So we did it with the students to get them to start being socially aware, and then they took the things that they found qualitatively to the local council, which was fantastic because the youth had a voice there. But what we knew we needed to do is, we wanted them to be free to choose however they wanted to model it. Obviously the model's a lot simpler than what we're talking about here. So we needed to find some models and simple models to be able to role model them for them, so that some students could at least have a choice about where to go. Exactly what you do, they have a starting point. But that took so much work, and you've just given ChatGPT, it sounds like you've just shared a solution that can just make things so much easier. So thank you so much.
Yeah, sure. Yeah, and just want to say, I really like what you are saying about giving students the option, so they choose the things they feel comfortable working about, and that's part of the reason I mentioned I wrote a short paper with somebody else in the special issue. We talk about love scenario, and you can choose the model you like in your background that you feel comfortable with. So I'm not born and raised in US. So I had my share of struggle not understanding the popular culture topic in the classroom. Like when professor talk about the icebreaker about Star Trek, I'm like, what are you talking about? It's not an icebreaker. It's scaring me away. I have no idea what you're talking about.
Yeah, yeah.
I really appreciate any professor who would be, considerate and allow students to go in the direction they feel comfortable with and don't take things for granted. But well, dragon is my personal taste. It's a year of dragon, so yeah.
That's exciting. And I think too, if you give students choice and they have ownership over it, and they're far more likely to be engaged. And I mean, I think that one of the problems is, I think I heard it earlier in a discussion as well too, is someone said, we expect students to think like we do and they don't. All student comes at a different starting point, and if they've got the choice about where they tap in, then they're generally tapping in at their starting point, and they're more likely to be able to keep building on their knowledge than asking them, as you say, to come to our decision and come to exactly where we are. But it definitely takes sometimes a change of mindset.
Yeah, exactly.
Yeah.
Thank you. I'm glad we think similarly.
Yeah. Thank you very much. That was great. Really, really
Thank
enjoyed
you for
it.
coming.
I'm going to be late to the next one, but that is fine.
Okay. Thank you. See you.
Bye-bye. I'm just going to read the
Bye.
chats before I go. Yeah, that chat GP stuff, thank you very much. Really, really
Sure.
good. And it's changes it from, because we know where we are here, there's all this, oh my God, what are we going to do with chat GTP? And the way that you've been talking about using it, just because as a model, like you rightly say, whatever you're doing, I mean, my biggest experience when I first started modeling and studying modeling was I realized that every different situation is going to use a different set of skills, and you can't be expected to know them all. It's impossible to have that repertoire of everything. And one of the key skills, I think, of being a modeler is being able to have the confidence to go and find or go and learn what you're going to need, or go and find the person that is an expert in that skill. And what you're talking about is now that GTP is now becoming one of those other yes, not expert, like anything, you always got to critique it, but it's becoming another resource for you to get the skills that you need to solve the problem.
Right. Yeah, exactly. I feel like it's a tool for those who need extra help. Like I'm not a native speaker, and I feel like my writing, my report and everything gets improved so much. Well, it's not really improved, but whatever I wrote and sent out is getting much better, because I feel like I have this extra person who can do extra double check my grammar and everything. So I'm well, ask ChatGPT to produce new things for you. That's not good, but ask it to give you some directions and to revise things for you. That's definitely quite helpful. And I mean, we're not getting rid of it, so why don't we just embrace it and just try find good ways to use it?
Yeah, no, I'm completely with you. Completely with you. Yeah, definitely. It shouldn't. Yeah, it's not going away. Instead of thinking it's this big, awful, evil thing in the corner, let's find out how to work with it. Yeah.
Right.
Thank you so much. Sorry, I would have held you up.
Yeah, go ahead.
So much.
It's really nice talking to you. Bye.
Yeah, nice to talk to you. Bye.
So we have a guest here. Do you have any question, or I'm just gonna end this session? Okay, I'm just gonna end this session.
Bye-bye.